Welcome back. In this session, we're going to move on to random forest. In the previous session, we covered bagging, which is random sampling with replacement. We did it on decision tree on the Titanic dataset. We did the bagging on top of the decision tree. Right, so random forest, what exactly is random forest? Let me just copy the descriptions that I have actually done slightly earlier, just so that you don't have to watch me type. There is this the original paper here of random forest, which is actually created by the AT&D T. Bell Laboratories. So let me just close that off. It's basically an ensemble of decision trees. Now, how is that different from what we did earlier? So let me explain. The training is via the bagging method, which is similar so far. It's repeated sampling with replacement. The difference is this. It's sample from samples. Okay, what do I mean by that? Now, the key difference between decision random forest versus the bagging of decision tree that we did is that it utilized uncorrelated trees. So just to further contrast between random forest and bagging, now random forest sample both the observations, which is the actual training data itself, as well as the features, whereas bagging samples only observation at random, and the underlying decision tree select the best feature when splitting a node. So in essence, decision tree will always result in the same feature, the best features, to actually split a node, whereby random forest decidedly or intentionally sample features. Okay, so that means they ignore other features when it's actually doing this sampling. So I guess the other way to think about it is that bagging will basically only focus on the training data itself. It will leave the features, meaning it will include all of the features, whereby random forest is the variation is that it will randomly select features. Okay, so with that basic foundation set, we are going to go into the start to actually implement the random forest. Now we already set up the earlier Titanic dataset, so we're going to continue using this same dataset. Okay, already preset that. So let me just from scikit-learn ensemble, we're going to import random forest classifier. Okay, and in terms of the accuracy score, I think they're all still there. Let me have a look. No, they're not. Okay, so I need to actually copy that across. The model that we were working with, which is the bagging one. So let me just come here. We need to actually copy the basic performance matrix. Let me copy those. Okay, so I've copied the model selection train test split. Okay, run that, and also the actual model selection cross-validation score, as well as the different matrix that we're going to utilize, which is the accuracy score, classification report, as well as the coefficient matrix. One more thing is that we're going to make use of this neat little functions that we actually did. And now that we've got all the basics that we've done, so we're just going to start instantiating now. Random forest classifier is equal to random forest classifier, and we're just not going to specify any of the parameters, just leave it at that. And random forest fit the data. We have the X train, and then we have the Y train. All right, okay, let's run now, and let's have a look at the actual performance print score of the whole lot here. Again, I'm not gonna type that all out. The only difference is that we want the random forest classifier. X train, Y train, X test, Y test training is equal to true. Let's print that out. So the accuracy score looks really good, but when you look at the actual average accuracy, it's only 74%. Now, if we look at the decision tree, average accuracy is 7724, which is better than random forest, but the actual variation is actually higher than the random forest itself. Now remember that we haven't actually trained the random forest or researched it, so so it may underperform, and which it did. So let's have a look at the test score. All right, the test score comes out as 6909, which is actually worse than the decision tree itself. Unfortunately, it didn't perform as well. Looks like it is suffering from the actual lower data, or the lower samples data. So that might be the key issue here. So maybe we'll actually try doing a bit of grid search and see if we can improve on the model itself. So from scikit-learn, we're going to import pipeline. Okay, and from scikit-learn model selection, we're going to import grid search. So the random forest classifier is the random forest classifier that so we're going to change the random state, keep it as 42. And in terms of the parameters grid search, okay, first is the maximum depth. We're going to set that as 3 or none. Okay, so that's the first one. And the next one is the minimum sample split. We're gonna set this 2, 3, and 10. So that's we change. Basically, these are the hyperparameters that we are tuning. So minimum samples leave, and we're gonna set that as 1, 3, and 10. And the bootstrap, we're gonna try it with true and false. Okay, and the criterion, we're gonna use Gini, and also the entropy. All right, that's the parameters that we're gonna sweep. So let's run the grid search. We're gonna store it in the variable called grid search, and run the actual grid search itself. Grid search cross validation. We're gonna feed the random forest classifier params grid, and I'm gonna use up all of the core on this computer. Cross validation is equal to 5, and verbose is equal to 1, and the scoring is equal to accuracy. Okay, accuracy. All right. Scoring, not score. Okay, so far so good. So we're gonna perform this grid search now and perform the fit on the training as well as the Y train data. So let's run this. All right, in total 5 falls for 72 candidates, totaling 360 fits. All right, it doesn't like it, so there's some error. Let me just have a look, and I'll search this through and I'll come back. Oh well, I'll figure that out. Samples. Okay, let's run this again. Just one typo can mess it up. Okay, now it's running happily now. It's done. Okay, so it took 5.9 seconds to run the whole thing. What we'd like to do is have a look at what are the actual best score that it comes up with. So that's the first thing. Best score, so it's 76.37. Is that better than the decision tree? Well, no, it's actually slightly better, even though we actually did a really quite thorough grid search. So let's have a look at the actual best estimator, and let's just get the parameters. Best estimator. Okay, so these are the best estimator, and the next thing that we want to do is actually print the score. Now remember, that is only for the in sample, so we want to see if it actually performed well out of sample. And let's run this, copy all of these. And run that. Okay, so 77.17 in sample, 77.17. That's not really exciting, so let's just have a look at it to see the 5 folds, see how well it actually performed, the 5 folds. I'm just going to leave it at that, let it run. It won't take long. It's about 6 seconds for 5 runs of this, so it's about 30 seconds. Oh, running tenfolds. Okay, you might want to accelerate this. I'm just gonna let it run and let you actually watch the whole thing. Okay, here we go. Average accuracy is 70-40. Did we actually improved? 70-40, well, not really. The standard deviation is actually worse now. That's funny. Okay, so let's just print score, and we're gonna repeat this, except this time around we're gonna have it as false. I guess our random forest was actually overfitting. Okay, so looking at outside, basically for the test score out of sample 7637, 7637. So that's basically the best that it can do, which is exactly the same as the performance of the underlying decision tree itself. Well, I think part of the problem with this is that we don't have a lot of features. We only have 3, remember. That's the first thing. The second thing is that we don't have a lot of data, and that might be what is actually causing the problem. What I would like you to do is actually walk through the process with some slight variation. Now this is for random forest, so the test size you might want to actually reduce it to 10%. I suggest you pause the video and run through this exercise yourself to basically give the random forest a bit more data to train on. I think with 70% held back just purely for training, 10% held back for test. I think in our case, 30% held back for test, it might be impacting on the actual performance for the random forest. So you might want to try to change that to 10%. And see whether the actual performance improve or not. So let's just pause the video. When you come back, I'm going to wrap up the lesson and tell you where to from here. Well, how was that? Well, I tried. I did the same exercise as you did. Well, it didn't turn out well at all. The accuracy score dropped further to 63%. Well, that's pretty disappointing. But that's okay. I think the problem lies in the fact that we have a small data set. Again, I'm kind of reiterating this, and I'm basically building you up a little bit to a big model that we'll be looking at later on with about, just under 900 samples. But what I really want to do right now is just to give you an experience of the workflow. And when we come back, we're gonna look at the together the extra trees, which is also another term for extremely randomized trees ensemble. So I look forward to seeing you then.